one dimensional harmonic oscillator. What is Now the question arises, what is a one dimensional harmonic oscillator? A harmonic oscillator is a particle or a point which oscillates about its mean position, which oscillates or perform Hello guys, today I am going to discuss linear harmonic oscillator. Linear harmonic oscillator. As you all know that a linear harmonic oscillator means a point or an object which exhibits simple harmonic motion along a straight line. So if we have a particle, say P at a point, at this point, then if it exhibits to and fro motion along this mean position, then such type of motion is called as simple harmonic motion, and this particle is called as linear harmonic oscillator. Now these linear harmonic oscillators have a potential V is equal to 1 by 2 k x square, where k is equal to omega by m, where k is equal to k by m, where omega is the angular frequency or classical frequency of the system. Now, initially, or in a continuous system, when we talk about a linear harmonic oscillator equation, what we observe is that it has a continuous energy, and its 0 point energy means its energy at the rest or in the ground state is found to be 0. Now, if we want to analyze this problem with the help of, now we want to analyze this equation with the help of quantum mechanics and see what else can be observed from this equation. To start with, as in a usual way, what we do is that first of all we find the potential of the particle, which has already been done here, and now the second step is to write a Schrodinger wave equation for this equation. So the Schrodinger wave equation can be written as minus h cross square over twice m d2 psi over dx square plus v psi is equal to e psi, where psi is a function of x. Note that we have taken d2 psi over dx square. It's because our harmonic oscillator is moving linearly. It means it's just a one-dimensional problem. So we need to focus only on the derivative with respect to x. So this one is your equation number 1, and this one is your equation number 2, or say 2 days. Now we want to simplify this equation and rewrite in a different way, and what we are doing is that we are dividing the whole equation with minus h cross square by 2m, and then rearranging every term on the left hand side. What we get is d2 psi over dx square plus or minus twice m over h cross square v psi plus twice me over h cross square psi is equal to 0. Now you can take d2 psi over dx square. Now what you can do is you can take a negative sign twice m over h cross square uh, outside the equation, and then we can simply write it. What we can do is that we can write it as minus uh, twice m over h cross square within bracket e minus v psi. ठीक है? So it's just simple manipulation. We have taken twice m over h cross square from both the terms as a common, and then the remaining term will be e minus v times psi is equal to 0. Now we are rewriting this equation as 2. Now, but from equation 1 we know that v is equal to 1 by 2 kx square. So what we can do simply is that from equation 1 and 2, from 1 and 2 we can write d2 psi over dx square plus or minus twice m over h cross square within bracket e minus half kx square is equal to half k, and k is equal to kx square. So k is equal to omega square omega by m, okay, half kx square kx square bracket close, and psi is equal to 0. So we have rewritten this equation in this form. Now to solve this equation, let's say that this equation is 3. Now this equation is a nonlinear differential equation, and it is difficult to solve this equation directly. So for that case, what we are going to do is that we are going to consider few of those terms as something else. For example, let us consider say alpha is equal to twice me over h cross square, and say beta is equal to beta square is equal to mk square over mk over h cross square. Beta square is equal to mk over h cross square. Then 3 can be easily written as d2 psi over dx square minus twice me. Twice me over h cross square is considered as alpha, so it will be plus with a negative sign, so it will be minus within bracket alpha, and then if you multiply by twice m over h square inside this, then 2 and 2 will be cancelled, and you will get mk over h cross square, which is beta square. So it will be minus beta square multiplied by psi is equal to 0. So my apologies, x square has been left. So this will be your new Schrodinger wave equation, and this equation has been obtained by transforming our original equation with the help of some transformations. Now, if you look at this equation, we need to solve this equation, but the x squared term, which is appearing in equation 4, it still keeps this equation as a nonlinear differential equation, hence solving it with usual methods is impossible. For this purpose, we again will make some substitutions. Again, we will make some substitution to simplify this equation bit further. So let xi is equal to under root beta times x. So this will implies d xi over dx is equal to under root beta. Similarly, we can calculate Now, we have taken the equation xi is equal to root beta x, and in this equation x is the independent variable. So it means we are replacing x by xi. It means that we are replacing the independent variable of this equation. So our aim is to calculate d2 psi over dx square in terms of xi. So for that purpose, we have considered d xi by dx is equal to root beta, and now we will calculate the first order derivative of psi with respect to x, and that can be written as d psi over d xi multiplied by d xi divided by dx. So we have already calculated dj by dx, so we can write it as root beta and then d psi over d psi. So we have calculated d psi over dx in terms of d psi over d xi. Now we want to calculate the double derivative of this equation, so we can write d2 psi over dx square is equal to root beta d over dx of d psi over d xi, and now this can be written as d over d xi of d psi over d xi multiplied by d xi over dx. So d xi and d xi can be cancelled, and we will get d2 psi over dx square, and again we know the value of, and again sorry, we forgot to write beta here, and again d xi by dx is equal to root beta, so we can write it as beta and then d2 psi over d xi square, equation number 5. So now we got almost everything, and then we can rewrite this equation number 4 as, we can rewrite this equation number 4 as, so in place of d2 psi over dx square, we have to write beta. So from 4 and 5, from equation 4 and 5 and 5, so from 4 and 5 we can write beta d2 psi over d xi square, d2 psi over d xi square minus alpha alpha and then minus beta square, and we know x is equal to xi over root beta, so x square is equal to xi square by beta, so it will be xi square by beta, the bracket will be closed, and then psi, which is now a function xi, is equal to 0. So if we simplify this equation, since we got beta here, so why don't we divide the whole equation by beta? If we do that, we will get d2 psi over d xi square minus alpha by beta, and this beta will be cancelled by this beta, minus beta xi square multiplied by psi as a function of xi is equal to 0. This is your equation number 6. So we finally got at a position in which our equation looks like this. Looks like this equation. If you trace back, there is a small mistake. If you trace back the negative sign here, you will find that it will be positive, so this equation will this equation will come to this form. So this equation again cannot be solved exactly, therefore we need to find asymptotic solution. This equation alone, though it's a very much simpler equation, but again finding the solution of this equation is very difficult. Hence, what we need to do is we have to guess a solution for this equation, and we will guess the solution of this equation in the form of asymptotic solution. Asymptotic solution, why we are using asymptotic solution? हम asymptotic solution क्यों यूज कर रहे हैं? Because psi is going from minus infinity to plus infinity. It means that the psi is ranging from minus infinity to plus infinity. But what is psi? Psi is a wave function of the particle, and if psi is a wave function of the particle, then it must have some physical significance. The first physical significance is that it will exist, means the psi will exist only at the points where there is a probability of finding the particle, and outside that region, means at infinity, the probability of finding the particle must be 0, and so as the wave function. So keeping that in mind, we are considering a solution of this equation of the form uh, okay, so these two things we need to keep in mind. But before that, if you look at this, the form of psi, if psi, say if psi tends to infinity, at that case, what will happen, that alpha by beta will be very, very less than psi square. So this equation can be modified and can be written as t2 psi over t psi square minus beta psi square of psi is equal to 0. So now it is a bit simpler equation, and as told earlier, that even though it's a bit simpler equation, but it cannot be solved, so we have to look for a asymptotic solution so as to ensure that the wave, there is no probability of finding the particle at the infinity. So for this purpose, let us consider a solution of the form psi is equal to, let us consider the solution psi is equal to, say, some constant c e to the power plus minus psi square by 2. But if you look at the positive value of psi, if you take psi as positive, then at infinity psi, the value of psi will be very large, and if the value of psi is large, then what will happen, the finding of probability at infinity is very large, which is not the case. So in the case of, if we consider psi as c e to the power minus psi square by 2, in that case, as psi increases, that e to the power minus infinity term will diminish, and there will be nearly 0 probability of finding the particle at infinity. So it means that this psi works as a solution to the above said equation, or equation number 7. So equation A can be a solution of equation 7. But this solution is not complete. It is just a part of the solution that we have extracted, because our original equation is alpha by beta minus beta psi square, and we have put a restriction that when psi square is greater than, when psi tends to infinity, this term will vanish, and then this equation resists to this equation. But what if psi does not approaches to, what about the reason in which psi is not infinite? In that case, if you solve this equation, some terms of psi must appear. But what will be the form of those equations, we don't know. So for that purpose, we will consider a general solution for equation 6 as psi as a function of psi is equal to e to the power minus psi squared by 2, and then multiplied by h xi, where h xi is a polynomial of xi which may be 1 plus xi square by factorial 2 or xi cube by factorial 3, etc., where we need to find the value of xi. So this is an unknown function. This is an unknown function which needs to be found. So if equation 9 is a solution of equation 6, then it must satisfy equation 7, then it must satisfy equation 6. So what we are going to do is we are going to take the derivative of equation 9, second derivative of equation 9, and then substitute it back into this equation. So here it is psi. So if we take d psi over d xi, what you will get, first of all you can differentiate h xi and you will get h dash of xi, and then e to the power minus xi is equal to 2. Plus, if you leave h xi as such, then you have to differentiate e to the power minus xi square by 2, and then the derivative of minus xi square by 2 will be minus xi. Now, what we have to do is that we have to differentiate this equation again. What I am going to do is I am going to take e to the power minus xi square by 2 out of these two parts, and then we will be left with h prime minus xi h. So this is your whole part. Now differentiating this equation again, d2 psi over d xi square will be, now if we differentiate e to the power minus xi square by 2, you will get e to the power minus xi square by 2, and then minus xi, that's what you will get, and here you will get s dash minus h xi, and then again e to the power minus xi square by 2, and then if you differentiate this equation, s double prime minus h minus xi h dash. So this is going to be your equation. So this is the value of d2 psi over d xi square. Now we can substitute this value in equation 1 here, and what we will get, why don't we take, but before doing that, why don't we take common e to the power minus xi square by 2 as common, so that we will get minus xi h dash minus plus xi square h plus h double dash minus h minus xi h dash, and a further simplification will lead to xi square by 2 within bracket h double dash, and then minus 2 xi h dash plus xi square minus 1 times h. This will be the value of d2 psi over d xi square. So now I am going to substitute this equation, this value here, and we will get e to the power minus xi square by 2 within bracket h double dash minus 2 xi h dash plus xi square minus 1 times h bracket will be closed, plus alpha by beta minus beta xi square, and then e to the power minus xi square by 2 times h is equal to 0. So if you take e to the power minus xi square by 2 as common, then the remaining coefficient will be 0, and in that case we will get h double dash minus 2 xi h dash plus xi square minus 1 times h plus alpha by beta minus beta xi square multiplied by h is equal to 0. And if we simplify further, we get h double dash minus 2 xi h dash plus h dash plus, if we take h as common, it will be xi square minus 1 plus alpha by beta minus beta xi square bracket close into h is equal to 0. Sorry for the mistakes. Sometimes when doing some calculation you make a mistake, so that's fine. So now this xi square will get cancelled with this xi square and we will left with h double dash minus twice xi h dash plus alpha by beta minus 1 times h is equal to 0. So this is your second order differential equation. It is a linear differential equation and it can be solved now. But to solve this equation, finally we have arrived at the standard form of the equation which needed to be solved. So our aim is to solve this equation, and here to solve this equation we will use series solution as our main tool to solve this equation. So first of all, I will write the form of the equation at the top of the board, and that will be h double dash minus 2 xi h dash plus alpha by beta minus 1 times h is equal to 0. So as mentioned earlier, this is your final equation. We want to solve this equation and we want to take the solution. Want to solve the equation in the terms of polynomials. So let us consider h. This is a function of xi is equal to summation running over n, and it will be your an xi to the power n. This is an xi to the power n. This is your series solution. So you can change the value of n from 0 to infinity. You will get a solution like a0 plus a1 xi plus a2 xi square and so on. Now we'll take the first and second derivative of this equation and then substitute back in our original equation. So if you take h prime of xi, it will be summation a n will be here xi to the power n minus 1, and then it will be n is equal to 1 to infinity, as n has been zoomed out of this equation, but don't consider that now. And now you can take s double dash of xi, and it will be summation running over n is equal to 0 to infinity n minus 1 times an to the power xi n minus 2. Now we can substitute all these values into this equation and we will get summation running over n minus 1 an xi to the power n minus 2 xi h dash will be summation running over n an xi to the power n minus 1 plus alpha by beta minus 1, and h will be summation running over n xi to the power n, and that will be equal to 0. So now look at the powers of these equations. Here the power will be xi to the power n, and here the power is xi to the power n, but at this place you get xi to the power n minus 2. So what we are going to do is we can write this equation as summation running over n minus 1 an xi to the power n minus 2, and then we are going to take the remaining terms as a common. We are going to take a summation running over n and an xi to the power n as common, and see what we get from here. From here we'll get alpha by beta minus 1. An xi to the power 1 has already taken into account, and now if we will come here we will get minus 2 and then n, and that's the end. Xi to the power n is equal to 0. So what we consider ascending series solution of this equation